Hello my dear students, welcome to video number 137 of the channel MALACHEMPHILIC, and this video is the 76th episode of Chemical Thermodynamics where the topic is second part of thermochemistry. So let's start. In the first part of thermochemistry, I have just discussed or revised or recapitulate that the concept of enthalpy. And there I told you that in under thermochemistry, we will discuss all this topic, enthalpy of reaction, enthalpy of formation, etc. So today we are going to discuss, or in this video, we will discuss on this enthalpy of reaction. So let's see. Enthalpy of reaction or heat of reaction. What is meant by that? This is the difference between the total enthalpies of all the product and all the reactant in a reaction. Because of this difference, energy is released or absorbed. And this difference in enthalpy or energy of the product and reactant, that is known as the enthalpy of the reaction or heat of the reaction. So therefore, this heat of the reaction, delta H reaction, is equal to the enthalpy of the product minus enthalpy of the reactant. Now the question is, 1 minute. Now the question is, why energy is released or absorbed during the chemical reaction? See, try to understand. See, this is one reactant molecule, that is A. It is diatomic molecule. It is reacting with another reacting molecule, that is B. And the product form is this AB. So what is happening here? During the chemical reaction, this AA bond must be broken. Similarly, BB bond must be broken, whereby energy is required. And when this product is formed, that means bond is formed between A and B, then what will happen? Energy is released. Okay. Now, this difference in energy, that means energy required to break the bonds, is different from energy released during the bond formation, and therefore either energy is released or absorbed during a chemical reaction. So heat absorbed or released during a chemical reaction due to the difference in energy of bond making and bond breaking. Now see, for exothermic reaction, for exothermic reaction, what is that? Energy is released. Exothermic means energy or heat. Energy is released. Energy is released means your delta H should be negative. When energy is released, then delta H is negative. So, delta H, that is negative. Right? How the delta H will be negative? Then what will happen? This enthalpy of the product must be less than enthalpy of the reactant. Then only energy is released. Now, for endothermic reaction, what will happen in endothermic reaction? Energy absorbed. Here energy is absorbed. Energy absorbed means this heat of the reaction, delta H reaction, that will be positive. When it will be positive? When this enthalpy of the products is greater than enthalpy of the reactant. Right? Now, another term I want to explain, that is known as the standard heat of reaction. Heat of reaction, which is denoted by delta H naught. Okay. So it is the heat of reaction under some standard condition. What is that condition? Standard condition is that pressure will be 1 atmosphere. Okay, that is always true. This one is always true. Say one reaction you are carrying out at high altitude where the pressure is less. Same reaction you are carrying out at low altitude where the pressure is more. Then the heat of the reaction will be different. So we have to take one standard condition, and that is 1 atmosphere pressure. We have to maintain that. Second thing is that it is for 1 molar aqueous solution. And the third one is that is not always true. That is temperature must be 298 Kelvin. Mostly we'll keep the temperature 298 Kelvin, but that is not always. Always is pressure must be kept 1 atmosphere. That is the standard condition, and 1 molar solution. Okay. Now let's solve this problem. Calculate heat of reaction at constant pressure and constant volume. Already in my last video I have discussed heat of the reaction, constant pressure, constant volume and their relation. For the reaction, what is the reaction? Reaction is ammonium nitrate is decomposed to nitrous oxide gas plus water liquid. What is given? Enthalpies of these reactants and products are given. So what you have to calculate? Heat of the reaction at constant pressure, that is delta H, and constant volume, that is delta E. So first we calculate delta H. Delta H is equal to enthalpy of product minus enthalpy of reactant. Now we'll see the enthalpy of the product. Product is nitrous oxide. So first one is, it is plus 80 kilojoules. And then what are the other product? Other product is this water. And water is minus 300 and it is 2 moles. So 2 into minus 300, this is for the products. This is the enthalpy of products. Minus enthalpy of reactant. Reactant is ammonium nitrate. What is that enthalpy? That enthalpy is minus 400. All these are given in kilojoules, right? So now we'll calculate it. This is 80 minus 600 minus plus 400. That means minus 200 plus 80. So it is minus 120 kilojoules. This is at constant pressure. Now at constant volume. So at constant volume, that heat of the reaction is equal to delta E, change in internal energy, right? Now we know that delta H is equal to delta E plus delta Ng, difference in the number of moles of the product and reactant, only gaseous reactants and products, then RT. Okay. Now, what is delta H? Delta H, just now we have calculated. This is minus 120 kilojoules. Delta E, and here delta Ng, that is the difference between the number of moles of the gaseous product and reactant. Here only one product is gaseous product, that is nitrous oxide. That is 1 minus 0, that means it is 1. So it is 1 into R, 8.314 into 10 to the power of minus 3, because you have to take in kilojoules, and temperature is 25 degrees centigrade. That means it is 298. So if you calculate, then delta E, that will be is equal to minus 120 and then minus this 8.314 into 10 to the power minus 3 into 298, and this will come as, if you calculate it, it will come minus 122.477 kilojoules. So this is the problem. Now coming to the factors affecting the heat of reaction. The first factor is the physical state of the reactants and product. So different physical state of the substance, so it is reactant or product, they have the different enthalpy. If the enthalpies are different for different physical state, then enthalpy change, that is HP minus HR, this enthalpy change during reaction also will be different, and especially when the reaction from gas to gas will have different enthalpy change than when the reaction taking place of the same substance of liquid or solid. Now let's take one example. See, this hydrogen gas plus half oxygen, this gas, when it is giving the product water molecule gas, 1 mole of water, then your delta H, that is minus 60 kilocalorie, this much of energy is released. But when this reaction is like this, hydrogen gas plus oxygen gas, but it is liquid water, that means physical state is different, physical state of the product is different, then delta H is minus 70 kilocalorie. Why? So here it is gaseous water molecule, the product is gas. Here the product is liquid, but the substance is same, both are water molecule. Then why this difference here? Here the difference is, here the gaseous product is formed, which is condensed to liquid water molecule, whereby energy is released. That means 10 kilocalorie extra energy is released. So it depends on the physical state of the reactants and products. Now temperature. Generally, if the temperature is higher, if temperature is increased, internal energy of the reactant also increase. And when internal energy increases, total energy or enthalpy or overall energy of the reactant also increases. When the overall energy increases, then energy difference, that is enthalpy change of the reactants and product also vary. So temperature has effect on the heat of the reaction. That means temperature will affect how much heat is released or absorbed. Now, pressure and volume. See, heat of the reaction at constant pressure, which is delta H, it is different from the heat of the reaction at constant volume. Heat of the reaction at constant volume is difference in the internal energy. Okay, why it is different? Especially for the gaseous reactant or gaseous reaction system, the pressure has significant effect. So this heat of the reaction, when it is carried out at constant pressure, must be different to that of when it is carried out at constant volume. Now, next point is solvent. So, heat of the reaction also depends on the solvent in which the reaction takes place. Next point is allotropic form. Different allotropic forms of the same elements will have different stabilities and different energy. So, same reactions when you are carrying out with different allotropic forms of the same substance, then energy difference between the reactants and products will be different, because the reactants will have different stabilities or energy in the different allotropic forms. Say for example, see this one, this carbon in the diamond form, allotropic form is diamond, plus oxygen, say this is carbon dioxide, say here it is delta H1, and this carbon when it is in the graphite form, another allotropic forms, plus oxygen, then carbon dioxide, then delta H2. Okay, here the substance is same carbon, but allotropic forms, different allotropic forms. Here delta H1 is not equal to delta H2. Now the last point, amount oblique stoichiometry. See, already I told you that enthalpy is an extensive property which depends on the quantity of the substance. So, more reactant means more heat will be evolved or more heat will be absorbed. Okay, so this is all about the different factors on which the heat of the reaction depends. Okay, now hope you have understood this discussion on this heat of the reaction. Next video I'll discuss the heat of formation. Okay, thank you.